All right, we're going to factor these trinomials, and when we factor them, what we're trying to do are find two numbers that multiply to equal this back and add to equal this middle. So it's often easier to think about what numbers multiply to equal the back versus adding up. There's lots of numbers that could add up to 4, but only a few numbers multiply to equal 3. So some people put this off to the side. They'll put like a 3 here and then say 1 times 3 or -1 times -3, and then they say, all right, 1 plus 3 is 4, -1 times plus -3 is -4, so that's not it. It must be this combination, and then they'll go ahead and write it as x plus 1, x plus 3. It doesn't matter which one goes where. You can have them in either order, and if you want to check to make sure you did it correctly, you can always do the model here. X times x is x squared. X times 1 is x. 3 times x is 3x. 3 times 1 is 3. We have an x squared, just like we have there. We have 1x plus 3x, that's 4x. And then we have the 3. So that works out. Some people like to work off of here. They'll work in the box to kind of get into this form here. Other people can just kind of go right to there. Either way, it doesn't matter. This is where we're trying to land, is right there. So on this one, I'm trying to think of two numbers that multiply to equal 8 and add to equal 6. And so I only have so many options. Again, it could have 1 and 8, but that adds up to 9. I could do 2 and 4, and that adds up to 6, and that's what I want. So we're going to write this as a plus 2, a plus 4. 2 times 4 is 8. 2 plus 4 is 6. If I were to check that out, I'd have a, 2, a, and 4. A times a is a squared. 2 times a is 2a. 4 times a is 4a. 4 times 2 is 8. Here's your a squared. It's 4a and 2a makes the 6a. And then we have the 8 that's in the back. So again, this is right here where we're trying to go. This is just to check our answer and see if we did it correctly. All right, so now I'm just going to kind of think through. All right, 27. I want numbers that multiply equal 27, but I need to add to equal -12. So because it's going to add to equal a negative, I'm thinking of two negatives. Two negatives would multiply to equal a positive and add. So 27, let's see, I could have -1 and -27, but if I add that up, that's too much. That doesn't give me -12. 2 doesn't go into 27, but 3 does. 3 times 9. -3 plus -9 is -12. Found my numbers. So I come over here and I go b minus 3. I'm doing minus because they're negative. And that's my answer. Again, I could check it out if I want, but I'm pretty confident that's going to work for us. Okay. I come here, I'm looking for two numbers that multiply equal -70. So because it's multiplying to equal negative, I know one of them has to be positive and one of them has to be negative. They're also adding to equal 3. So if I did -70 and +1, that adds up to -69. That's not going to work. If I change the positive negative, again, that's just too big of a gap. I need it to be just 3. So you could try 35 and 2, but again, that's a gap of 33. That's not going to work. And then you could try 5 and I think 14, but that's a gap of 9. I think the one that's obvious to us is 10 and 7. They're 3 away from each other. The question is, which one is it? Is it +10 and -7 or -10 and +7? So again, they got to add to equal +3. So I want the 10 and -7 option. X plus 10 and x minus 7. 10 times -7 is -70. 10 plus -7 is +3. Again, I could make the box to check and see, but that's I'm pretty sure I've got that. Okay. Our next one here, I need to multiply to equal -72. So that one may be a little trickier. Probably in the top of your head, you don't have a lot of things that multiply to equal 72. So if you use a calculator, just kind of divide it out. It's 2 and 36, 3 and 24. Those, again, are too big. We're trying to get just a gap of 6. Eventually, what you're going to come up with is 12 and 6. 12 times 6 is 72. Because it's negative, I need one of these to be negative, one of them to be positive. So again, the question is, well, which one do I want positive, which one negative? Since I want them to add to equal positive 6, I need the 12, the bigger one, to be the positive one. Okay, so now I can write x plus 12 and x minus 6, and there's my answer. Okay, here's a familiar one, x squared minus 25. I have two terms that are subtracting, and just like we were talking about the other day, if I have two terms that are subtracting, I can just think of it as a difference of squares. What times itself equals x squared? That would be x times x. 25 is 5 times 5, and then I would make it a plus and a minus. Now you can think of this the same way we've done the other 5, and that is what multiplies to equal negative 25 and adds to equal 0, because there is no middle term here. And that means that 5 and negative 5 have to be opposite so that they cancel each other to give us that 0 in the middle. Okay? So again, just an old concept. Number 7 is another one like that. So I'm going to put my parentheses down. What times itself equals 25? That's 5 times 5. What times itself equals x to the 6? That's x to the third, x to the third. What times itself equals 64? That's 8 and 8. And the y to the fourth would be y squared and y squared. Make one of these plus, one of these minus, and there we go. 5x to the third plus 8x squared times 5x to the third minus 8y squared. Okay. On this one, I need two numbers that multiply to equal 4 and add to equal negative 4. So first off, you think of 4 and 1. But 4 plus 1 is 5. If I made it negative 4 and negative 1, that adds up to negative 5. And so the only other option for us is 2 and 2. If I add that up, that's positive 4. I want it to be negative 4, so I'm going to make it negative 2 and negative 2. So I get x minus 2 times x minus 2. That's totally fine, but since it is the same thing, if you wanted to write it as x minus 2 squared, that would be totally fine as well. A little bit later chapter, we're going to actually want to write it like that. Okay. So similar idea here. What multiplies by itself to equal 25 and adds to equal negative 10? So 25 is 25 and 1, but that adds up to 26, not 10. If I make them both negative, that's not going to help. The only other options for us are 5 and 5. But 5 plus 5 is positive 10. I want these to be negative, so I'm going to use negative 5 and negative 5. So negative 5 times negative 5 is 25. Negative 5 plus negative 5 is negative 10. Because they are the same, if I want to write this as y minus 5 squared, I could totally do that, and there's our answer. Either one of those is fine. Okay. Last one gives us another look at that. 36 has lots of things that multiply, 1 and 36, but that adds up to 37. 2 and 18, but that adds up to, I'll put these down, that adds up to 37. That adds up to 20. That adds up to 15. That adds up to 13. We're getting closer. But 6 and 6. 6 times 6 is 36, and 6 plus 6 is 12. So we're going to use 6 here, and 6. And again, just because that is the same, we could write this as z plus 6 squared. Either one of those answers would be fine.